Hi everybody, this is my first time in the Nick Valley Theatre.
Hold on then.
The wrong way.
No, I was going to say this slide.
Oh, very good. So before I kick it off, I'm going to just introduce myself. So I'm Ed Curry, Professor of Data Science University of Galway, and also the Director for the Galway side of the Insight Centre for Data Analytics. And I'm going to talk today at a pretty high level about the kind of opportunity and the challenges that exist with AI and with data, and to kind of just point to some of the kind of trends that are there. No equations in the talk, so you can relax. I'm sure John and Cole have a bit more detail on their one later on. My background is in the area of kind of distributed systems and looking at kind of data management there, so basically processing lots and lots of streams of data. So originally we'd call these kind of middleware systems, we'd consider ourselves software engineers, and over time, the last 20 years, this has molded into an example of data science. So the challenges that we face with AI and data. Well, the first one, and one that's probably the most obvious, is the challenges around compute and the necessity for data. This is a slide, it's a couple of years old, and it basically, well, about a year and a half old, I think it is. And basically it talks about an interview with Sam Altman where he's kind of detailing what did it take to build GPT-4. And OpenAI haven't released an awful lot of official data this year, kind of gleaning different pieces of information from different interviews. But what we saw is that basically this was our Moore's law in terms of compute, and then effectively our modern era of AI is basically moved from a doubling every 14 months, sorry, a doubling of capacity every 18 months to basically every 3 to 4 months we were seeing kind of these models having more and more and more compute. Which basically got to the point of last year where effectively OpenAI said, we've used all the data that we can. We basically processed everything, and you can imagine the levels of complexity, the amount of GPUs that are involved. You're literally talking about, last year I think they spent €2 billion on basically GPU infrastructure for OpenAI. So they've processed all the data, what's next? So this is the big challenge. Surprisingly, for any other company that's trying to do data, what you'll find is that the vast majority of companies do struggle to actually have data to run their AI on. So you have these large data companies, Google, Microsoft, Amazon, etc. They have lots of data, lots of compute, and then you start looking at other companies, and what they're really struggling is how do I find high quality data to be able to train my AI systems? And this is a survey that was done for a bunch of CEOs that talked about what's one of the biggest challenges you have delivering your AI strategy. And they pointed to this lack of data that existed inside their organizations, or even an inability to be able to get that data, to know the quality of that data, to be able to train their AI systems. So a real kind of dichotomy there between the two of them. There's also serious challenges around the balance of the data, the bias that exists in the data. And then there's also significant challenges about, well, why do we have this issue? Why can't we get access to our data? And one of the biggest issues there is the complexity of the data that we create as a society. So what we have is basically very, very, relational database tables. If you looked 20 years ago, when I'd have kind of been at the start of my career, I can see Ted there would have taught me relational databases over at GMIT. And things did fit into tables. You could have tens of attributes, hundreds of attributes in a table, but you have everything fitting nicely in tables, and things worked, and they were fine. The challenge is that you shoot on 2 decades later, and the data that we're now trying to model has thousands of attributes, tens of thousands of attributes, hundreds of thousands of attributes. And the complexity, there isn't a consistent data model for it. It's just lots and lots of data with lots and lots of attributes. And that's what we're working with. So we have this long tail of data semantics, which basically means we have all of these attributes in this long tail, but we're still using primarily relational database technologies. Now, there are other things we're using as well, but this is still the main kind of technology that we're looking at. And that's a real challenge to be able to bring data and to make it ready for AI. And I think John will talk about some strategies for that later on. Another big challenge that we have with delivering AI is the fact that our data is fundamentally distributed and it's fundamentally decentralized. So from a physical point of view, if you go into most organizations, they don't have all their data in one single place, except for OpenAI that bring it together into one of these large data centers where they can process everything. But the majority of organizations have their data spread across different sites, different physical locations, and there's a challenge to bring it together. The other challenge that we have is at the semantic level, is because people have different conceptualizations of the world that can conflict. They can still be valid, they can still be true, but people model data in different ways. So it's really hard to reconcile those semantic models that people create when they're created from different disciplines. A chemist looks at the world different than a physicist looks at the world, even though they can be modeling the same thing. So there's ambiguity, there's vagueness, there's multiple conceptualizations of reality. The type of data that we're moving from is not even in relational databases. It's actually well beyond that now. So it's looking at multimodal data, whether it's sound, audio, video images, and trying to process that. And that's creating more and more complexity in the data that we're working with. And then we have facts, and we have alternative facts, we have subjectivity. Everyone views the world in a different way. And when you start looking at social media data, you can actually see this explode in terms of just the amount of subjective ways of reasoning, of looking at the world. It doesn't necessarily mean they're wrong. They're just, again, different conceptualizations, different opinions, and very much personalized to the individual. If you're looking at querying this type of data, well, if I want to find myself some reasonably priced restaurants in London, and if Elon Musk is looking to find reasonably priced restaurants in London, reasonable is very subjective there. Very, very subjective. I'm quite happy with Papa John's Pizza. Not too sure Elon would be as pleased with Papa John's Pizza. But this points back to a challenge that we have. If the data is subjective, we're recognizing the fact that we all have our own subjective opinions. The systems that we build, the data management systems that we build, need to recognize that subjectivity. They need to understand that need to personalize, to understand what reasonable is for me, what reasonable is for a student, what reasonable is for a billionaire. And then finally, we have this notion of hallucinations. And this is, I think, the magic and the mystery and the fear that comes from AI as well. Is basically the models themselves are designed in a way that they will prefer to have something that looks better than something that is true, effectively, just to summarize. So this is the real challenge that we have to overcome, and I think we will overcome. But I think one really nice example that was done of this was the notion of asking ChatGPT about the benefits of playing the accordion while riding a motorcycle. Okay, you can see we have a big challenge here, but it's still an incredibly impressive system to come up with that and to be able to try to reason with you and to convince you of how important and what a good practice that is. So these are the real challenges that we have, but there are answers to these as well. And then finally we talk about copyright. So interestingly, OpenAI is the single largest copyright infringer in the history of the planet. It's taken everything that it can get its hands on, thrown into a model. It's very interesting that no one has tried to buy or purchase it because there's a massive liability on it. So it's very much a nice, self-contained playground to see what this technology can do. Companies are investing in it. But there is a really, really big challenge with this. This is not something that can last forever, and it is something that organizations would not find acceptable beyond looking at ChatGPT as a tool that they're using for kind of toy scenarios. So the current status quo around data governance, around AI governance, will have to change as well. And that's where we're going to start talking about some of the opportunities that start to present in this landscape. So the first thing is, data infrastructure is a difficult thing to try to convince people to invest in, and investing in data management is very challenging. But I believe that generative AI, foundation models, will be the killer app for data infrastructure. And if you think of it, we've had these killer apps for hardware platforms, for software platforms. So we had VisiCal. Probably anyone hands up? I know one man that knows VisiCal. Anyone else? I know two that know VisiCal. So VisiCal was it was the killer app for the Macintosh back in the day. Basically, nobody else had a spreadsheet type functionality, and that became their killer app. Microsoft Word became the killer app for the Windows Intel platform. Basically, that Office suite, that's why people bought Windows. It wasn't for Windows themselves, it was the fact that you had Office, and that basically launched that company. For the web, Netscape was the killer app, because everyone could use it. And for the internet itself, FTP wasn't that fun. News groups, yeah, fine. But once the web came, once you had a browser, that became the killer app for internet. And then for mobile phones, the killer app became the App Store. Because once you had an App Store, your phone changed from something that you had a conversation and text messages with to actually being a mobile computing device, which yes, you can make phone calls, but actually you spend a lot of time in your apps, whether it's web, email, whatever else, connecting with your people. So these are all different types of killer apps. And I think what we'll see with generative AI is that it will be the killer app that motivates why people and organizations need to have appropriate data infrastructure to go with it. And I think this will lead to a paradigm shift in how we actually interact and work with our data. So does anybody recognize this? Okay, the same two guys I know recognize it. Actually three, Mr. Conroy there behind as well. For those of you under the age of, oh dear, probably 30, maybe 25, this was the internet in 1995. This was Yahoo. And when you hopped on and you used Netscape, and you went to Yahoo, they had this wonderful directory, all of these different links, and these different categories. And if you clicked on this, you could actually find different web pages. There was no search, there was nothing like that. It was basically a large directory, like a telephone book, that basically categorized the web. And what was interesting about this is at the time in 1995, there was about 100,000 websites. This Yahoo was one of the biggest companies in the world at the time. It became one of the biggest companies in the world. But the way it was built is that it actually had what we would call kind of exact results. Because if I was creating a web page about Liverpool, I would submit, I'd find the category here, you know, sports, soccer, teams in England, Liverpool. I'd find the category, I'd submit my web page there, and then Yahoo would verify that. So it was high quality, exact results, human curated. It was fantastic, it changed the world. Fast forward a mere 3 years later, and then suddenly we got this. Everyone recognizes this. So rather than having this structure, what we found is that once you actually went past 100,000 websites and you went to 2.5 million websites, well actually Yahoo couldn't cope with that, they couldn't categorize them enough. And what they found is that what people were interested in, they didn't necessarily understand what category would it be in, so they just enter keywords. So they enter in keywords, Liverpool, soccer, results. They'd click search, and then basically the results that would come back would be computed. And what that meant is that you weren't dealing with an exact result, a high quality result here, but rather you got back a set of results, and then it was your job as a human to go and figure out, well, what's the results that I'm looking for? What's the information? What web page here would have that information that I need? And then you process it. So it was computed with approximate results. Fast forward a decade and a bit onwards, we went from 2.5 million web pages to 700 million web pages. And what Yahoo noticed is that, well, actually, people aren't really interested in web pages. People want answers. That's really what they're really looking for. So what they did was they started to add in these knowledge panes. So when people would type in questions, if Google actually had a knowledge graph that actually contained that information, a high quality, human curated, crowd curated knowledge graph, they would also provide answers in addition to the web pages as well. And that's basically the paradigm that we have for information management and information access at a global scale for the next 10 years. And then in 2022, 23-ish, the world changed again. And suddenly we have this thing, and we can ask it questions and it'll give us answers, and you can even have a conversation. No, I didn't really mean that, I meant this other thing. But it wasn't just giving us answers, it could actually create content for us. So now if I'm trying to write an article about Liverpool, is my job not to find the pages on Liverpool, read those web pages, and then write the article? Or do I start having conversations, say, hey, I need to write an article about Liverpool, I'd like to talk about this and this. So suddenly this notion of being able to generate content changes the paradigm again. At the moment, the web is about 2 billion pages large. Are they approximate results? Are they hallucinated results? Are they a combination of both? We don't know, but definitely the paradigm is starting to change now. And even the paradigm of how we create content will start to change. That's why the generative part here is so important, because it allows us to reach into the tasks that people are doing. Why do you go to Google? Is it because you're searching for a flight? Is it because you're writing a report? Is it because you're creating a presentation? Are you doing some research? So it's understanding that relationship, and that's the relationship that's going to start to change. The other thing that's starting to change in the last kind of 9 months, do you remember I mentioned before about these, that OpenAI had basically computed everything that was there to compute? But what we started to see, and this is across OpenAI, Microsoft, a number of different organizations, is that the cost of actually running AI is decreasing drastically. So you're looking at tenfold improvements at inference time on this over the last couple of, basically the last kind of 2 years. And what this means is that what used to take an entire small city worth of energy is now becoming into the realms of smaller organizations. So this, I think, is a big shift as well. So the models themselves will still need to be trained, but once they're trained, the ability to adapt and customize them basically opens them up to be used by an awful lot of organizations. And this is a real opportunity that AI can be more broadly used without having to have those large data centers. Another key thing becomes then that the data quality that we have will be the core of having trustworthy data-centric AI. So if we can have high quality data, if we can ensure that it's accurate when we train these models, the chances of them hallucinating becomes less. And we have a scenario where we can actually have more faith in what those results are. I never think you'll fully trust them in the same way you want to build an autopilot to fly a plane, which will be on later, which will be on autopilot. I hope it's not a generative AI LLM flying it, because I'd be jumping off that. But we'll start to get to a point where actually, do you know what, it's good enough. It's good enough for what we're trying to achieve. It's good enough, like the Google results were good enough for us. So depending on the task, I think we've got a big opportunity here. Remember the copyright thing we talked about? That can't continue. And what we've seen with the European Commission is that they have, over the last 3 years, launched a European data strategy, where they're basically saying what we need in Europe is the ability to have large-scale data sharing infrastructure. We need to have clear data governance frameworks around that data, and we need to ensure that organizations follow that. So if you think of GDPR, which is very much kind of focusing on personal data and the rules about processing that, but the Data Act and the Data Governance Act is starting to broaden that, to start saying we need to have more formal data governance for all types of data, not just personal data. And as part of that strategy, they are saying that we need to build what they call a data space for Europe, and basically this is an idea of what that is. A data space can provide a clear framework from a business, legal, and a technical point of view to support data sharing within the data ecosystem of multiple parties. So what the Commission is recognizing is that we do not have an OpenAI style, Microsoft style, Google style organization in Europe that collects data at scale. But what we need to do is to have public infrastructure that can support that, or to support private organizations to work together to be able to scale and to be able to pool their data together. But it's not a case of donating that data for free. It will be a clear data governance framework that basically recognizes that data sharing can take place as part of a transaction, whether that's monitoring or something else. So this is part of the vision, and it's part of putting in place the infrastructure that's needed to be able to train these large models. To give an idea of the strategy, I won't go into this in too much detail, but basically the Commission is trying to identify different sectors where they believe these common European data spaces are needed. And one of those is in fact the health sector, with the Common European Health Data Space, which actually is coming into operation over the kind of next 18 months. And our health records here in Ireland will be anonymised, aggregated, and then shared for secondary use with other parts of Europe as well. And this is like a continental, European-wide effort to be able to do that. There's other examples of this in areas like energy, mobility, and basically this is part of the vision to be able to bring that data infrastructure together. At the same time, they have these acts around data. They also have the AI Act. Hands up if people are familiar with the AI Act? Techie room? Okay, so give it another 2 years, everyone's hand will be up. Because the AI Act is now moving from the point of view, it's moving into implementation over the next couple of years. And I think it could have a very profound shift on the way that we actually design and build systems. Because in the same way now, if you're a data scientist and you're working with personal data, you actually have to know about GDPR. You have to know what are the implications of using this data. Are we using it for the purpose that we've collected it? Well, the AI Act will start to regulate the use of AI and automated decision making across a number of different areas. Very, very briefly, I'm not a lawyer, but basically looking at what kind of system, what kind of decisions are you making, and then basically what's the level of risk that's associated with it, and then looking at different types of regulatory approaches to be able to support that. What that really means for us as technical people is that if we are building an automated decision-making system, we're going to have to understand how does our system relate to the AI Act, are we conformant with it, and that will involve a process of kind of training, educating, identifying best practices amongst our community to be able to respond to that. As I said to Ray earlier on, if you want to stop a scrum straight away, just ask a question about GDPR. There's many GDPR issues here. What? The AI Act will be on steroids in probably 5 years' time. But what that really means is the question we shouldn't be fearful of the question. What it means is that we need as a community to understand, well, what does that mean? What's the heuristic? What's the steps we need to go through to verify that? And, oh, actually, no, there's no GDPR issue. Let's move on. So it's about education. It's about giving us all those tools. So then we're going to talk a little bit about what's the opportunity. So we have these large-scale data spaces being built within Europe. We have AI, and we have a reasonable understanding of how we want to try to regulate that within Europe. And basically, the vision and the relationship is that we can use our data spaces to create high-quality data for training. We can have a community of users around the data that's been created. We can have a clear governance framework. What's the legalities of using that data? Have people given permission for their data to be used to train AI models? Have companies given permission, and not even permission, have companies made their data available where they can actually receive some monetary reward for actually using that to train an AI model? So data spaces will give that for AI, and then what AI can give us for data spaces, again, those generative AI tools, the ability to be able to analyze and to work and to interact with those large quantities of data to be able to extract value, to be able to deal with that kind of long tail of data, the different formats that we have. So there's a real opportunity there. And even though this is, at this stage, still conceptual, it is moving very, very fast. So the data spaces themselves are, as I said, the European health data space is kind of coming into effect in the next year or so. And the tools from an LLM point of view, from a foundation model point of view, we're seeing that this is very feasible and very, very probable. So basically what you look at there is you have all of your data in your data space or your data infrastructure. You'll use that to train a kind of centralized foundation model, and then you'll try to basically adapt that foundation model to very specific downstream tasks. That means that you might expect this to be done by the larger companies that have the compute capacity, but then the adaptation stage is something that should be achievable by many organizations. And I think what we're seeing is you can have more trust in an AI model or a foundation model when it's been targeted at a very specific task, because it means you can test for that, you can have requirements that in verification and basically form a verification of result if needed. So there's a lot of potential and a lot of opportunity with that. Finally, the last point I'll make is when we start looking at those knowledge graphs and we start looking at high quality data that has insight in it, what's really fascinating with LLMs is that they're able to process that data in different types of formats. So it could be in knowledge graphs, probabilistic logic, it can be in programming languages. All of these are different structures that actually contain high quality, potentially high quality knowledge that can be leveraged by the LLM. So by looking at bringing together not only data, which is a large scale, here's the web, but if you say, here's the web, here's our GitHub repository that actually has some really good understandings of how to design software in different ways. Here's our knowledge graph for the medical records for all of the patients that we have in a particular hospital. By looking at those high quality sources of data, I think we can actually have an awful lot of benefit in how we build and create new types of AI systems. And fundamentally what this means is that we can't start thinking about AI life cycles and data life cycles as being separate things. They can't even be separate teams anymore. Because fundamentally, for you to build an AI system, for you to stand over that AI system, you need to know what data has been used to build the model. Where did it come from? Is it legally valid that I can use that data? What's the quality of the data? Is the data still accurate? How do I understand it as concept driven? So you need to know so much about the data to be able to understand how your model will perform, that we need to start looking at basically having our data management lifecycle and our AI model lifecycle as a single lifecycle. And that's it for me. Thanks very much.
Thanks, Ed. That's some really, really good data points there and some good stories. Does anybody have any questions for Ed before he goes? Remember,
I have to get on a bus in
He's gotta get on a
35 minutes. There is in fact a flight. People go, there's no flight at Dublin Airport. There's actually a flight at midnight, 1 minute past midnight, that goes from Dublin to Athens. It does exist. Or else I'll be sleeping in the airport tonight.
Question. So,
Please.
with the regulations that are coming within the EU, with the conceptual data that we have here, the progress and pace that, let's say, other entities like the US or input in China is exponentially increasing. Will we be able to keep with the pace to be able to implement this before, let's say, we start getting recursive training or very large, say the space becomes saturated with an entity, the US or China?
Yeah, look, it's a really good question. And one of the biggest fears that people have around the AI Act, and I'm not a proponent of the AI Act, it's just this is the reality that we're dealing with, is that it's going to stifle innovation. And that's a real danger. That is a real danger. Being frank, I think we've already lost that war in Europe. So I think what we need to figure out, what's the next battle? And I think it's not that I like regulation, but there is a need for us to recognize that you can't train models like OpenAI. You just can't go out there and take all that copyrighted material. Because it's okay, how quickly, the guy from Lord of the Rings or the guy from the Game of Thrones, he's complaining that his book has been stolen and he's multi-millionaire. That's okay. But the reality is, the next thing is health records, the next thing is my data, and then people go, oh, hold on, what's going on there? So I think the market will want the security of a regulation in terms of control, in terms of consent. And I think if you look at Apple as an organization, they see that as an advantage for them because they kind of see themselves as, they have their ecosystem, we can talk about that a good thing or a bad thing, but they do say, we don't sell your data. Our product is our iPhone, our product is our iPad, our product is not your data, which is not the same for all the organizations. So I think there's an opportunity for us there in terms of it might be more acceptable, the types of solutions that are built in that regulation. That's not to say that China and the US can't adopt that regulation in the morning and still have the advantages of it as well. That's the reality. I think in Ireland, I think the important thing for us is to understand where both of these will meet, because that's our opportunities, is the interface between Europe and the US, which is a difficult thing to do at the moment, but I think that's where we have to grab it and to translate and then leverage the benefit globally for ourselves.
Thank you.
Just you talked about progression from Yahoo's directory to Google's robots.x and onto conversations to interact with knowledge workers. What can you see kind of landscape going on from there? What we're looking likely to progress into, like from that to conversation to.
I think so. The example I gave, I didn't have enough time to talk about it, but if you remember the Star Trek Next Generation, there was no books on that ship. There was no library where let's go and look stuff up. They just asked the computer do this, computer do that, computer do this, computer would do stuff, do something else. We're basically there today. We are so close to a scenario like that. The big challenge we have is that it's stuck with GPT or Copilot. Give that another 5 years of development. That's great. The hard part is, how do we bring all of our data to it in a way that the computer knows more about me, knows everything about me when maybe I don't want that to be the case. So I think from a technical point of view, we're pretty much there, but it's a case of how do we now want that to be shaped? How do we want that to be acceptable to us as a society? Do you want your phone to literally know everything about you and to be able to do that? So I think, I think it's more of a conversation now about what type of society do we want to build with these technologies, because the technologies are here. Star Trek was a utopian society, so they were all very happy. I don't think we're a utopian society, but we have technology that's very close to that. Not really an answer, more of a scary. Please.
Do you think that we'll put more efforts into creating our own LLMs similar to the other countries like OpenAI, so we can maybe limit misinformation or understand the bias that's being created within these LLMs?
Absolutely, yeah. So I think what's really cool about what OpenAI have done, and the other, like Facebook done it, actually before them, but it's a different conversation. It's the generality of it. So you can do anything, you can ask any question, you're going to get something back. I think for a lot of task-specific models, you're going to have probably data that's highly relevant to it, that's hopefully high quality. And when you start training task-specific LLMs on much more curated data, the quality shoot up, hallucinations drop. That's roughly what we're saying. So I think yes, I think there's significant opportunities to train and to adapt those open models and so on.
So as this data space will be created, so right now as engineers we don't have access to the data, and due to this data access we can train our models, and a lot of people will train. Do we have, because it is training a model from scratch is compute intensive. So is Europe or like particularly is working on that area as well, like having GPUs and data centers?
They are, so it's not part of this talk, but the Commission is part of their AI strategy is building what they call AI factories. So they are investing, I think it's the region of €1 billion in infrastructure, and now they're looking at these AI gigafactories. Where that comes from, they're effectively looking at those machines maybe being about €2 billion each. So that at least there's effort underway to have infrastructure at a similar scale to what OpenAI has for Europe. What they'll be used for, because there's a lot of public money involved, there'll definitely be open science, open access, but also there's private organisations involved as well. So it probably will be a public-private partnership kind of model. Some of it's public and some of it's kind of commercially focused as well. But I think, I genuinely think we have to ask ourselves, how many large language models do we actually need? Right, we've just, Alton just told us, yeah, we've used all of them, there's no more data. We're not going to get any benefits by throwing more data at it. So now the model needs to get smarter, not more data. So I would question the strategy a little bit. At the same time, we do need some serious infrastructure in Europe.
Do you think the EU will lower the bar on data privacy to allow, like what you talked about, state medical data to, allow that for a bigger picture use?
Yeah, it's a good question, and the European health data space does not lower the bar. What it does is, it's only working at aggregated data, and it's already been anonymized before that. So they are trying to hold the line there on that, which I think makes sense. And I think it's all GDPR compliant, regulatory compliant. But I think the next step would be, well, I've got my personal health records. I'd like to donate them to a particular initiative that's, researching cancer, as an example. So how can you make those personal donations where you actually might give an awful lot more detail than just the aggregated data?
Yeah, I think there's a potential issue with pseudo-anonymized data that isn't allowed to be used for the US. That's okay to use, so we're, in the EU we're kind of behind the curve with this. Is there any move on that potentially?
I wouldn't be an expert on that, to be honest. I wouldn't be able to give you a great answer on that. No, not my cup of tea.
Just one more, if you don't mind, if that's the case.
Sure.
So essentially, does that mean that probably the winning strategy from a European perspective would be to allow a large language model to develop that would be the co-ubiquitous one, but to create essentially a data firewall around Europe and European data to be able to pull that in and maybe create our own ones? Or are we going to focus mostly on establishing our own LLMs for that with the kind of perhaps less efficient way of doing it?
Yeah, so there are European LLMs at the moment. Minstrel is one. There's kind of the guys in Finland. They created one as well. They were bought by AMD recently. So they are there. I don't think we need to create a firewall around our data. What we just need is clear governance mechanisms, and then for those governance mechanisms to be respected and enforced where needed. I think we do need to move away from the Wild West kind of, we can just train anything and we'll be fine. You can do that when you have deep pockets and you can out-lawyer somebody. That's okay, but it's not really how we want to build build a society, and in that world, will you ever want to hand over your medical records, all your medical records, or, you know, or similar to an organisation? If you don't trust them, what will they do with it? So I think there is a benefit that we can get if we can figure out how do we mature ourselves so that we can share data that is respected, that we can say, hey, I share it, actually, I unshare it, I don't want you to have access to it. Or if I'm a company, I'm giving you my data and I'm expecting if you make money out of that, I'm going to see some monetary benefit from that as well. You know, in the same way with any kind of value chain, you know, money has to flow back the value chain, or else how's it going to work? We don't really do that too well in the digital space at the moment. So I think that's where the opportunity is. And from a technology point of view, we need the infrastructure, we need to be building models in Europe, because if we don't build them here, we lose the capacity to be able to do that kind of work. So it's as simple as that from a skills point of view, from a capability point of view. These things become no-brainers as well.
Thank you.
One more question. Are the models like is GDPR compliant?
I'm not sure about Mistral, but I do know there's a number of European LLMs that are legally compliant, whether it's GDPR or copyright. There's many of them. It's just because OpenAI is used everything. And in fairness to them, they are working their way through the copyright holders, handing out checks as well. So they are trying to do it, but it's just a different approach, different philosophy.